The goal of the project 6G Shine is to research new technology components for the sixth generation of cellular mobile communication, or in short 6G. This development is done together with 11 other European partners in a consortium led by the University of Aalborg. The focus topic of the project is subnetworks. These are local, highly interactive and reliable networks, for example, within machines, within production cells, in cars, in classrooms. We take care of dependable communication for local, close user groups in particularly challenging use cases. At FraunhoferIIS, we focus on the topic of hyper-reliable wireless communication for industrial subnetworks. This is especially challenging with cycle times of 1 millisecond. This is a time frame that a machine needs to exchange data with its central control unit, and it is not possible to simply retransmit data in case a transmission error occurs. And in industrial environments, transmission errors are more likely to occur due to restricted installation space, obstacles in between the device and the base station, or simply because of the highly reflective environment. Our solution is cooperative communication. So we provide the means that participants in the communication network can support each other. Concretely, we are using macrodiversity. That means that participants are not only interested in the data related to them, but also in data related to the other participants. They can then, so to say, piggyback that data onto their own transmission. And by that, they can act as some repeaters for the other participants. By using coding techniques, this piggybacking actually does not cost any more transmission resources than a usual transmission, and therefore is extremely efficient. To be able to do the proper coding, each participant has to know whom he is supposed to support. This association problem we are solving with opportunistic technologies for network-coded cooperation. To prove the capabilities of our system, we have set up a simulation of the overall concept. In other words, we have developed several hypotheses for solution which are based on 6G Shine and the use cases that have been analyzed there, and evaluated that with a network simulator. For this, we've chosen a cycle time of 250 microseconds, which is approximately 10 times faster of what is achievable with 5G release 15 at the moment. The result is that we achieve an increase in reliability by the factor of 1000, and we do not need to adapt the cycle time for this. And this holds true even if there are some obstacles in between in some of the links. So the next step is to do this testing also with the real equipment with over-the-air transmission, and to prove that our theory really works in practice. For that, we are setting up a proof of concept demonstrator at the moment, and we are bringing that to different environments to be able to test our system and quantify it and qualify it in depth.